Welcome everyone. Congratulations on completing Algorand building blocks and code. You've covered fundamental and now you're ready to dive into really exciting stuff. In this section, we will cover Algorand smart contracts, the programmable layer that turns Algorand from just a payment network into a full-featured platform for decentralized applications. By the end of this video, you will understand what smart contracts are on Algorand, how they work under the hood, what programming languages you can use to build them, and most importantly, what incredible possibilities they unlock for building real world applications. So let's start. What exactly is a smart contract on Algorand? Think of them as programs that live on the blockchain, but not just any programs. These are special programs that you can deploy to the Algorand network, and once they are there, anyone can interact with them. Here's where it gets really cool. With smart contracts, you can write your business logic, basically all the rules and functions that make your applications work, and deploy it directly to the blockchain. Want to create a voting system, or a marketplace, or a gaming application? Smart contracts let you build all of that in a way that's secure, scalable, and completely decentralized. Now, you might be thinking, okay, but what language do I write these in? And this is where Algorand really shines. You can write your smart contracts in either Algorand TypeScript or Algorand Python. And here's the beautiful part. Both of these are what we call supersets of their regular languages. What that means is they are high-level languages that are much easier to work with than the low-level stuff happening under the hood. Let me walk you through what actually happens when you write your code. When you write in Algorand TypeScript or in Algorand Python, it compiles down to something called TEAL. That stands for Transaction Execution Approval Language. Think of TEAL as being similar to assembly language that the Algorand virtual machine can understand and execute. Speaking of Algorand virtual machine, this is really the heart of everything. It's this process that runs on every single node in the network, constantly evaluating and processing transactions. Pretty amazing when you think about it. Your code is running simultaneously across thousands of computers around the world. Now here's something really important about Algorand smart contracts. What's really exciting is that your smart contracts can actually do once they are running. They can modify their own state. They can access real-time information from the blockchain, like checking account balances or looking at other transactions. They can even execute what are called as inner transactions, basically making other transactions happen as part of their execution. The bottom line is this. Algorand smart contracts give you everything you need to build serious, production-ready, decentralized applications. They are secure because they run on the blockchain, they are scalable because of Algorand's incredible performance, and they are accessible because you can write them in languages you probably already know. Whether you're building DeFi applications, NFT platforms, gaming experiences, or really any kind of decentralized application, Algorand smart contracts provide you the foundation you need to make it happen. Now that we have an overview of the basics of smart contracts, let's dive into application account. Every single smart contract comes with its own associated account. Think of this as like an escrow account for your application. This account can hold algo tokens, it can receive tokens from other users, and it can also send out tokens. This application account works just like any regular account you would have on Algorand. It can hold Algorand standard assets, we call those ESAs, which are basically any token that can exist on the network. But here's the key thing to remember. The smart contract itself isn't the account. So let's say your smart contract has an application ID of 1234. That's how your network identifies the program. But then there's also a completely separate account address, maybe something like ABC123, and that's the actual wallet that can hold funds. The cool part is this. In your smart contract code, let's say you have a simple Hello World application. You can write logic that tells this account what to do with its funds. Unlike your personal account, where you sign transactions with your private key, the application account doesn't need signatures. The smart contract logic itself determines when to send or receive funds. So you could write a method that says send 5 algos to this address, and the application account will execute that transaction automatically based on your programmed conditions. This opens up so many possibilities for your business logic. If you want to create a crowdfunding platform, the smart contracts account can hold all the contributed funds. If you're building a marketplace, the account can hold payments in escrow until transactions are completed. It's incredibly powerful. Just remember, and this is important, the smart contract itself isn't the account. They are separate things. The smart contract is the program with your logic, and the account is like wallet that belongs to the program. Now, let's talk about something that's really important for keeping Algorand fast and efficient. It's the resource usage. Smart contracts on Algorand can't just access any data on the blockchain whenever they want. Instead, you need to tell them ahead of time what resources they will need to look at. Let me give you an example. Say you have a smart contract with a method called as get asset balance. Maybe it checks how many of a specific token someone owns. Well, to make this work, you need to tell the smart contract two things upfront: which account you want to check and which asset you're asking about. Why do we do this? The answer is efficiency. If smart contracts could just search through the entire blockchain looking for data, it would slow everything down massively. But when you provide these resource references ahead of time, the network can grab exactly what it needs quickly and efficiently. You provide these references using what we call reference arrays. Basically, just list of the account addresses, asset IDs, or other resources your smart contract will need. And here's the good news. If you're using AlgoKit, it actually handles a lot of this automatically for you behind the scenes. There's a limit though. You can reference up to 8 different resources per transaction. But if you're working with atomic groups, multiple transactions that execute together, those resources can be shared across all the transactions in the group. Let's talk about where your smart contract can actually store data. There are 3 different types of storages: global storage, which is accessible to all the users; local storage, which keeps data specific to each user who opts in; and box storage, which allows flexible, large data containers for the contract. All these different storages serve a different purpose. First, we have global storage. This is like the main storage for your smart contract. Data that everyone can access and that's relevant to the entire application. Maybe it's the total supply of tokens you have issued or the current price in a marketplace. Global storage can hold up to 64 key value pairs with a total size limit of 8 kilobytes. This data is accessible to anyone interacting with your application. Then there is local storage. This is user specific data that gets created when someone opts into your application. Think of it like a personal folder for each user. Maybe it's their high score in a game or their preferences in an app. Each user gets up to 16 key value pairs, totaling 2 kilobytes. But here's something important to remember: users can delete their own local storage at any time. So don't put critical application data there that you absolutely need to keep around. Finally, there's box storage, and this is where things get really flexible. Each box can store up to 32 kilobytes of data. And here's the kicker: you can create as many boxes as you want. So theoretically, you could store unlimited amounts of data using box storage. This is perfect for applications that need to store lots of information, maybe user profiles, transaction histories, or complex game states. One thing to keep in mind with all these storage types is that they affect your minimum balance requirements. Basically, you're paying for the storage space you use on the blockchain. Now, here's where things get really exciting. It's the inner transactions. This is what allows smart contracts to interact with each other and with the broader ecosystem. With inner transactions, your smart contract can do almost anything that a regular user can do. If you want to create a new asset, your smart contracts can do that. If you want to send payments to other accounts, your smart contract can handle that too. Remember that application account we talked about earlier? Inner transactions are sent from that account. So, if your smart contract decides it needs to send 10 algos to someone, it uses an inner transaction to send that payment from its account. The system is designed to be very powerful. Each smart contract call can execute up to 256 inner transactions, and they all execute atomically. That means either all of them succeed or none of them do. This gives you incredible reliability for complex operations. This composability between applications is what makes Algorand ecosystem so powerful. You're not building in isolation. You're building components that can work together with other applications to create experiences that none of them could achieve alone. And that's what makes Algorand smart contracts so compelling for building serious applications. You get the security and decentralization of blockchain, the performance and efficiency of Algorand's consensus mechanism, and the flexibility to build complex interconnected systems. These advanced features, application accounts, efficient resource usage, flexible storage options, and inner transactions give you everything you need to build production ready decentralized applications that can compete with traditional centralized systems. And now that we understand Algorand smart contracts can do, let's talk about how you actually build them. I'm going to walk you through the complete development lifecycle from that first empty folder all the way to having a live smart contract that people can interact with on the blockchain. This is the real world process that every Algorand developer follows. And by the end of this video, you'll know exactly what step involves and why it matters. So, the first step is project initialization, and this is setting up your foundation. So, let's start at the very beginning. This is where everything begins, and honestly, it's way easier than you might think. When you're ready to start building, you'll run a single command, algokit init. That's it. This one command does a ton of heavy lifting for you. It scaffolds out your entire project structure, sets up all the folders you need, installs all the dependency, and basically gives you a complete development environment ready to go. Think of it like getting a blueprint for your house. You don't have to figure out where the kitchen should go or how to wire the electricity. The blueprint gives you a proven structure that just works. That's what AlgoKit Init does for your smart contract project. You will get the folders for your contract code, your tests, your deployment scripts, and everything else you need. It's like having an experienced developer set everything up for you from day one. Also, you need to run AlgoKit localnet start. Once your project is set up, the next step is implementing your smart contract logic. This is where you get to be creative and build the actual functionality that makes your application unique. This is where you'll define all your methods, basically all the different ways that people can interact with your smart contract. Maybe you're building a voting system, so you'll have methods like cast vote or calculate results. Or maybe you're building a marketplace, so you'll have methods for listing items and making purchases. You will also define what kind of storage your smart contract uses. Remember those storage types we talked about earlier? This is where you decide what data needs to be stored globally, what should be stored per user, and whether you need to store any of that flexible box storage. Now, you're going to see some terms thrown around a lot during development, and I want to demystify them for you right now. You'll see AVIs, you'll see ARC4, and you'll see ARC56. Don't let this intimidate you. They're actually pretty simple concepts. ABI stands for Application Binary Interface, and ARC4 and ARC56 are just standards that help you define how people interact with your smart contract. Think of it like a restaurant menu. The menu tells you what dishes are available, what ingredients they contain, and how much they cost. Similarly, these standards let you specify what methods your smart contract has, what parameters they need, and what they return. This makes life so much easier for anyone who wants to use your smart contract. Instead of having to guess how to interact with it, they can look at this interface and know what exactly they are working with. Once you've written your smart contract logic, the next step is building it and generating artifacts. This is where your human readable code gets transformed into something the blockchain can understand and execute. You will have to run another simple command, algokit run build. Behind the scenes, this does some pretty sophisticated stuff. For example, if you wrote your contract in Algorand TypeScript or Algorand Python, it compiles that down to Teal. Remember, that's the transaction execution approval language that's closer to assembly code that the Algorand virtual machine can execute. But the build process creates more than just the executable code. It generates several important artifacts that you'll use throughout the rest of your development process. First, you'll get the Teal code I mentioned. That is what actually runs on the blockchain. You'll also get ARC56 JSON file, which contains all the metadata about your contract. This file lists all your methods, describes what they do, explains how to call them. Basically, it's like a documentation that other developers and tools can read automatically. But here's probably the coolest part. The build process also generates what's called a typed app client. This is a client that you can use in both your backend and frontend to interact with your smart contract. Think about how powerful this is. Instead of having to manually construct transactions and figure out all the low level details of blockchain interaction, you get a clean typed client that exposes all your smart contract methods as simple function calls. It even includes helper methods like a deploy function that we'll use to get our contract onto the blockchain. This client makes your smart contract feel like any other API you would work with. You just import it, call the methods you need, and everything else is handled for you. Now, before you deploy anything to the blockchain, you absolutely want to test it thoroughly. Once something is deployed to a blockchain, it's much harder to fix if something goes wrong. So, testing is crucial. You can write both unit tests and integration tests. Unit tests check individual methods in isolation, making sure each piece of functionality works exactly as expected. Integration tests check how all the pieces work together, simulating real world usage scenarios. The great thing about Algorand development is that you can test everything locally before spending any real money on development. You can spin up a local blockchain, deploy your contracts there, and put it through its paces without any risk. Remember to start your local net before building and testing it out. Now, this testing phase often reveals edge cases you haven't thought through or helps you optimize the code for better performance. Once your contract is tested and ready, it's time to deploy it to a network. This is where your code actually becomes a living, breathing smart contract that anyone can interact with. You might deploy it to localnet first, then move to testnet, and then to mainnet. Now, testnet is a network that works exactly like the main network but uses test tokens instead of the real ones. It's like finally testing and getting feedbacks of users without any financial risk. When you're confident everything works perfectly, you can deploy it to mainnet, which is the real Algorand network, where your contract will be available to users worldwide. The deployment process uses that typed client we generated earlier. You'll call the deploy method, specify any initial parameters your contract needs, and sends the transaction to the network. Within seconds, your smart contract will be live and have its own application ID that people can use to find and interact with. You can follow the command given to deploy it to any specific network. Finally, once your contract is deployed, you can start interacting with it. This is where all your hard work pays off. Users can call your smart contract methods. Your contract can execute its logic, transfer funds, store data, and do everything you programmed it to do. You can interact with your contract through that same typed client you used for your deployment. Your front-end application can call contract methods just like they would call any other API. Also, you can have your own backend services that can integrate your contract to build more complex workflows. And because everything is on the blockchain, all interactions are transparent, verifiable, and permanent. There are also a few different tools available in the AlgoKit ecosystem to help with this. First, we have LoRa, which is an Explorer UI tool specifically built for AlgoKit projects. You can use LoRa to deploy, inspect, and interact with your smart contract visually, and we'll walk through that in the next section. For applications that need a custom user interface, you will typically build a front-end, which is a React app, for example, that connects to the smart contract. Now, if you want to enable wallet connections in the front-end, we will use Wallet, which is a handy React hook library that lets users connect their wallets like Pera or DeFi, switch accounts, and sign transactions. Now, to make smart contracts call easier and more type-safe, we also use AlgoKit utils. This gives us a generated client for our contract so that we can call methods like .hello or any other methods that you have specified in your contract without worrying about the low-level transaction building. So whether you're using LoRa or building a full front-end app with Use Wallet and AlgoKit utils, you'll have everything you need to interact with contracts on Algorand quickly and safely. Users can trust that your contract will behave exactly as programmed, and you can build applications that don't require users to trust you personally. They trust the code. This development lifecycle, from initialization to live interaction, is what every successful Algorand application goes through. And the beautiful thing is that AlgoKit makes each step straightforward and well documented. So, whether you're building your first smart contract or your 50th, following this process ensures that you end up with robust, reliable, and professional applications that users can depend on. In our next video, we'll actually walk through this entire process step by step, building a real smart contract from scratch. So, in the next section, we'll go through how we can use AlgoKit init to build applications and how we can compile and deploy smart contracts. And we will see both of these in Algorand Python and Algorand TypeScript. So thank you so much for taking out time for this section. And let's go over to the next section.